proof. So then your reasoning will be definition of a isosceles triangle. So if its two sides are the same, then it's isosceles. We put this in another notes day, the vertex angle, base angles, and all that stuff. But just as a reminder, those are the parts. Okay, these are also new proof reasons. They're kind of like, you know how you have your go-tos, like the reflexive and vertical angle theorem? These ones are used if you're stuck and need another part. And I'll show you once we get to proofs where they come from. But I think you already know kind of this stuff because, like, if you knew these two sides were the same, then the base angles are the same. These are the same. I think you knew that, did you? For isosceles triangle, maybe? No. Well, now you do. There you go. All right. So if two sides are the same, then the base angles are, and then vice versa. So this is the converse. This is like if two base angles are the same, then you can say the two sides are. So with the side stuff, you're going to be setting things equal, which is like the best. And then the angle stuff with these, you're just going to have to double one of the angles in your triangle. You just have to figure out which one's equal. This I think you already knew. If it's equilateral, then it's equiangular. Did you know? And if it's equiangular, then it's equilateral. These are called corollaries. They come from the other theorems. You don't need to know that. That's just a fun fact for today. So, this thing makes it sound really fancy than what it is. We're going to be drawing these like 80,000 times next in Unit 10 when we find areas of triangles and stuff. But say we've got an isosceles triangle and we draw a line straight through like the middle of it. So what I mean by the middle of it is like these two angles are the same. So you're going to draw a line straight through the isosceles triangle with those angles being the same. It forces this to be boxed up. So right angles, and these two are the same. So if you draw the line straight through the middle of an isosceles triangle, that's like a bad way to say it, but then that's perpendicular. It makes the height, you know, height of a triangle. Okay, anyway. All right, so all of these first couple are like puzzles. That's why I like them. Essentially what you do for the angle stuff is in isosceles triangle, two angles are the same. So just write, like you have to know which one to double, essentially. So like for this guy, it's like a sideways isosceles triangle. You see these ticks, you know? So like what you have to do is figure out which angle is doubled. So like if this is 50, so is this. And then you just do your 180 stuff to get the other angle. So you would do like, I mean, we could set up an algebra question, but you would just do x plus 50 equals 180. So 80, right? And then the other one's like the same thing, but now you're doubling the variable, which is kind of weird, but it's still like the same vibe. It's a vibe, apparently. So like these two are the same. So you just have to figure out which angle is doubled. So the y is, so that's like kind of whatever, freak you out a little bit. But it just means that you're going to go y plus 100 equals 180. And then that's pretty much it. I like these. Okay. So you do like a little alg action. Oops, I can subtract, don't worry. And you can get your answer. So, I know you guys know how to do algebra, so I just kind of ran through that. But yeah, just figure out what angle you have to double, okay? Then for these other ones, like number 2 is kind of weird because you have to like, this is where I say it's like a puzzle. So ACT loves these where you just try to figure out as many angles as you can and then you'll hopefully figure it out, okay? So like Because to be honest, I started with this one, you know, and I was like, oh, it's just like the other ones, you know, here's an isosceles triangle. And then I'm like, oh, I'll just double, what would that be? The x, right? Like those would be the same angles then, because those are the base angles. But then it's like I go to add it up to 180 and I'm like, cool, no numbers. So you have to like figure something out some other way. So, I mean, the only number you're given is 40, so I guess we're going to go with that. And 40's in an isosceles triangle. So what I'm going to do is, what do you want to do? I'm going to call this, like these two would be the same, right? I'll call it M for math. Isn't that cute? Okay. So I'm going to figure out that angle, like those two, by doing the same way I did the other ones. So I'm going to do 2m's. So I'll just write m plus 40 equals 180. And then I'll use it to figure out like the y and the x. So I get 2m plus 40 equals 180. So 70. So that angle is like, maybe I should write, this is 70, right? Like right here. So like to find y, you see the linear pair? See it? So like this is the 70 we found and this is the y. It's kind of what I'm trying to do here. So like to figure out y, I'm going to do 180 minus 70. So then I have the 110, so then I can find x. So it's like you just kind of work around the picture to try to get as much stuff as you can, and then add up to 180. That's like so many things in here. So like you're going to go to find x, you're going to take the 2 x's and the 110 and set it equal to 180. Okay. Okay. So we get 2x equals 70, so 35. There you go. And there it is. That's it. Okay. It's not too bad. Not too bad. Okay. Hey, you got a grade on your notes, just so you know. You're not taking them all. It's like the easiest thing to get points for. All right. Number 3. Do you know the answer?
Yes.
90. Yeah, this is a theorem. So if these are the same and these are equal, this is 90. Box it up. Okay. All right, that was fun. Okay, this guy. Look at all the angles are the same. So that means the sides are. Yay. And then for x, oh, do you know what each angle is then?
60.
Yeah, it's 60. Because you can take 180 divided by 3. All these are always 60. So for x, you could do like 2 different ways. You could linear pair action, or you could add these up to get x. Because it's a remote interiors add up to the exterior. So it's up to you. So you could subtract from 180, or you could do add up the remote interiors. Okay? All right, ready to juice it up? This is a good time. This I got from an ACT. I just got rid of the options. Haha. Okay. So, ACT loves this because they try to like figure out, boys, turn around. Okay, they try to like make you do multiple skills, like multiple geometry skills in one problem. So we didn't do circles yet, but like I feel like you already know what a circle is, I am assuming. Okay, so if O is the center of the circle, okay, What that means is if this was a center, all the radius or radii are the same. So no matter where you draw them, they're all going to be equal. So this was like a sneaky way to show you there's an isosceles triangle in there. And where is it? Here. Oh. Okay. So that I throw in. Then we've got parallel, which is fun. Okay, parallel. I'm not going to mess with that yet because I don't know what I need to find. And then they said ABO's 24. Oh, they already wrote that. Okay, there it is. And then OBC. Oh, and there's these. Okay, they already marked it in, so we're good. And we need to find BOC, this. Okay, so this is a multi-stepper. Okay? And it's going to be a little sass. We'll try. Okay. Isosceles triangle, right? So, if you're doing angles in there, two of them are going to be the same. And the two that are the same are the base angles. But look at what happens, right? Aren't these the same? Right? I'm going to call those Y. Okay? Just because I need something, I don't have a number for him. So we're going to do that. And if that's Y, this guy's Y. Right? So I use the isosceles stuff to get equal angles. Then, they're not going to say parallel for fun. Okay? You're going to have to use it. So I'm going to draw my transversal next to all the angle stuff that is not there. And if you can see it, these two angles are same side interior. So they're making you do circles. Guys, stop. Circles, parallel, isosceles triangles in one problem. So what you're going to do is you're going to take all that pink highlighted stuff and add them all up to 180. Okay, so you're going to go 24 plus Y plus Y plus Y equals 180 because they're same side interior angles. And guess what? How am I supposed to know this? You don't. That's part of the fun. Okay? You don't know. You're going to have to just use all these tools and figure it out. Okay? So that's what makes this so hard. So you're going to get 3y plus 24 equals 180. Move that over 52. So algebra, there you go. Okay, so y is 52. So that's this guy, 52, 52, right? So now I can figure out x. Oops. Because think about it. We've got the 52 and the 52, and these two are the same, right? So now we can figure out x. Oh, for crying out loud. So then what you're going to do to figure out x is you're going to take x plus 52 plus 52 equals 180. Okay. So it's pretty tricky to get it. And they're going to just give you something random. They don't give us like, oh, here's all the weird, like they'll show us all the weird parallel angle problems, but they're all so different that it's just like, you got to just figure it out somehow, okay? All right? So there are some on the homework that are a little challenging. I want you to see if you can get them, okay? Because remember, homework is just evidence of struggle. So as long as you can show evidence of struggle, you're going to be good. All right, now proofs. Do you see the picture? Okay, do they look similar? Like they're the same picture, but one's upside down, essentially, right? Okay, this is a clue to use isosceles stuff. Okay, so for this kind of picture, you're probably going to use isosceles things, okay? So we're going to do our same proofs like we do all the time. So you're going to say what you're going to prove goes last. So angle 5 congruent to angle 6, okay? And then you're going to start with red and feel the vibes, right? So you're going to go angle 1 congruent to angle 2 given fab. So you mark it on. Sorry, this picture's not supposed to have those ticks there. Like on that AC one. It's kind of annoying. Okay, congruent part. Cool, done. Next congruent part. Given, where's that? BC? Okay, those two. And then you move on to blue, and you're like, cool, this is where I do reflexive and vertical angle theorem, right? But if you notice, if you look at these these triangles, see that tick's not supposed to be there. Sorry, that black. Oh, it's okay. Here, wait. I'll just like cover it up. See, it's not there. It's just a fat line. Just go with it. All right, so there's no X, you know what I mean? Or there's no like shared side, so you're like, what the heck? This is the clue that your new go-to is one of those isosceles things, okay? So this is the tricky one. Tricky. New go-to. Okay, so here what you got to do. Do you see this giant triangle? It's giant. See the giant? And do you see how we've got some angles down here marked up? Okay, we got some angles down there. If the base angles are congruent, then the two sides are. So that's your third thing, your third part. Okay? Turn around. You've been gone. You need to pay attention. So if these two base angles congruent, then you can say AB is congruent to AE because base angles are congruent, so then two sides are. And that's a new reason from above, from before. Okay? So that's like your new ones. But it's used mostly in just this kind of picture. So at least you got kind of like some backing with it. Okay? So then after you finish your rainbow, you do your triangles just like usual. So you're going to go triangle ABC is congruent to triangle AED. And then this is where you're going to look at, okay, side, angle, side, angle, side. Well, I've got two S's and an A, so there's only one option. So side, angle, side. Okay? So two S's and an A, I don't even have to think really. It's going to be side, angle, side. Okay? And then, per usual, every single time, CP, okay? It always follows triangle congruence. Okay. Next one. So this triangle is isosceles. So triangle VYW is isosceles. Start, and then you just go after it. You do your first congruent part. So XY congruent to ZY given. Write this down, Aiden. Okay. So that's given, so you're going to mark it up. Okay. Then you do your next one. You're like, sweet, feeling vibes. This is cool. We got 6 and 7, or 5 and 6, geez. Given. And then you're like, feeling it, blue, reflexive vertical angle theorem. Oh, wait, denied. Okay. Because you don't have, it's these things again, these outside guys. There's no vertical angle theorem. There's no reflexive. Like, what the heck? So then you're like, oh, hey, that looks like one giant triangle. See that? See it? Look at that thing. But it's upside down. Who cares? No one cares, right? No one. You're going to be good. So you've got a giant upside down isosceles. Okay? So that giant upside down isosceles can tell you that these angles are the same. Yeah. Wow. So angle 1 congruent to angle 2, and then the reasoning is literally, oh, two sides were equal, congruent. Then the base angles are congruent. So that's those new ones. So they're your new go-tos. So if you don't have vertical angle theorem, don't have reflexive, then you do this weird isosceles stuff. That's new today, okay? And then you've completed the rainbow. So now you do triangles. You might get some anxiety because there's a lot of blanks left, but we'll be okay. So XVY congruent to triangle ZWY. I did blue, green, nothing for the marks. Blue marking, green nothing, no markings. All right, what do I got? 2 A's and an S, hey? So it's this one or this one. So side connecting the angles, is it marked? This little dinky guy? Nope. So angle, side. It can't be ASA because the side between them is not marked. That XV and WZ, that's not marked. So, all right, now we're going to follow CPCTC, and then you're like, cool, I don't know what to write. So, for step 5, remember you've got choices. So, we could do the stuff in the yellow triangles that aren't marked yet. I could do angle XYV. I could do ZYW. So those two angles, I hate using 3 letters, but it's fine. And then we do XV and WZ aren't marked. And WY and VY aren't marked. So it's basically the ticks that aren't there yet, right? So I need to look at that they want this triangle to be isosceles. So they want this middle guy to be isosceles, right? So for an isosceles triangle, you need 2 sides the same. Exactly. So you need, this is your only option. It has to be those two. WY congruent to VY by CPCTC, because then they'd be isosceles triangle. And then if you guess, you probably get right. Definition of isosceles triangle. And then that's it. So, like I said, on the homework,